welcome to True Projects. In this video, we are going to explain about the project, which is multi-receiver data authorization with data search for data sharing in cloud-assisted IOV. So before getting into the execution, first let's understand what is the project about. Consider a scenario where a fleet of delivery trucks are navigating through a city. Each truck is equipped with sensors that monitor real-time traffic conditions, road hazards, and even weather updates. These vehicles communicate with each other and the central traffic using Internet of Vehicles for optimizing routes, reducing delays, and also enhancing overall delivery efficiency. However, these trucks they send sensitive information. So they send sensitive data about their locations, operations to cloud servers for analysis and decision making. Serious security and privacy concerns arise. If this sensitive information is intercepted or manipulated by unauthorized entities, it could lead to significant disruptions such as misdirected deliveries or compromised operational data. Therefore, while IOV offers significant benefits in streamlining transportation, ensuring security and privacy of the data involved is critical to maintaining the trust and safety in these advanced systems. So, current encryption methods like public key encryption with the keyword search, that is PEKS, come with a significant limitation. They only permit users to search through their own data. This constraint hinders users from tapping into the vast resources available within Internet of Vehicles, which could offer valuable insights and information. Furthermore, existing encryption methods designed for multiple receivers often struggle to balance efficient data sharing with effective search capabilities. As a result, users may face unnecessary complications and delays when trying to access the data they need, which undermines the overall efficiency of the system. So, to overcome all the challenges, in this project, we securely share and search the data within the Internet of Vehicles. So, for that, here we propose multiple receiver data authorization with data search, which is MRDADS scheme. So this system is designed to allow multiple users to access and share encrypted information safely. And here each vehicle is assigned with the partial and full keys. So they are assigned with the both partial and full keys, which are essential for encrypting the data they collect. This encryption process ensures that sensitive information like traffic conditions, accident reports, and the distance to nearby vehicles remains protected while still being shareable. By using these keys, the MRDADA scheme enables vehicles to not only share the critical information securely but also search through encrypted data effectively, making it easier for users to access the information they need in real time. In this project, we incorporate the creation of encrypted trapdoor list. So in this project, we create an encrypted trapdoor list that holds encrypted location information of the vehicles. When a vehicle requests data, the cloud utilizes different algorithms to perform efficient searches. So these searches can include counting traffic or calculating distances to nearby vehicles. Once the cloud processes the request, it sends the results back to the vehicles. This method allows the vehicles to decrypt the information it receives, enabling it to access important insights while maintaining the security and privacy of the data throughout the process. So, to tackle the risk of the incorrect data being introduced by cloud servers or potential attackers, here in this project we introduce Wegman Carter authentication as an extension. So, this algorithm creates an authentication code for the search results before they are sent out. When vehicles receive the results along with this code, they independently generate their own code based on the received data and then compare it with the one that was transmitted. If both the codes match, it verifies the integrity of the data, ensuring that vehicles are relying on accurate information, which helps minimizing the chances of accidents due to misinformation. So, this is all about the theoretical concept of the project. Now, to execute this project, we need some basic requirements, which are hardware requirements and software requirements. So, coming to hardware requirements, we need processor of i5 and above, RAM of 8 GB and above, ROM of 20 GB and above, and Windows of operating system of Windows. And software requirements are Python ideally. Now, let's execute the project. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. And these three files contain Python code related to the project. And these two are the run.bat files. Instead of executing the project through command line interface, we have created this Windows bat file. Here, first we need to double click on run cloud server.bat file to start the server. That is cloud server. So double click on that. So cloud server has been hosted. I mean cloud server is started. Now let's run the application. So click on that, double click on that. Simulation.py file is compiled, and this is the graphical user interface of the project, which is built using Tkinter framework. Now let's start executing. So now first what we have to do is we need to generate IOV vehicles. That means we need to initiate the Internet of Vehicles. For that, we need to specify how many number of vehicles that we want to generate. So we want to generate 30 vehicles. So I'm specifying, I'm giving the input as 30. Now let's click on generate IOV network button. So click on that. Here, if you observe all the 30 vehicles, that means 30 red color circles have been generated, which represents the Internet of Vehicles. Each vehicle has its own label. Now, what we have to do is we need to generate keys for each vehicle. So let's click on setup and full key generation link. So click on that. Here for each vehicle, a private key has been generated and a public key has been generated. Now we need to send the data. That means we need to send the encrypted data. For that, we need to click on encrypt and outsource location. So by clicking on that, the data from all the vehicles, it will be encrypted and it will be sent to the cloud. So click on this encrypt and outsource link. So this is the data generated from IOV 0, that is vehicle number 0, and this is in encrypted format. Similarly, for vehicle number 1, this is the data generated from vehicle number 1 and it is encrypted. And here also we have encrypted data generated by vehicle 2. So similarly, for all the 30 vehicles, data has been generated and it is encrypted. And if you open cloud, this is the cloud server. So here we can observe that encrypted data is received. Now we will search the request. So for that, first we have to select the vehicle number. So let's select vehicle number 8. And now we need to click on search encrypted data. So when we search for the vehicle number 8, so this is the vehicle number 8 where it want to find the information. So it will find the information from all this top 5 vehicles. So these are the top 5 vehicles from where the encrypted data has been searched. And moreover, Wegman authentication code will show the successful operation of the data search. So here, by using this Wegman authentication code, it will indicate that a successful operation confirming that the cloud has provided genuine results to the vehicles. Now let's repeat the process. So let's search using other vehicles. So let's search using vehicle number 17. Click on search encrypted data. So we have searched for vehicle number 17, and these are the top 5 vehicles found for the vehicle number 17. And this is the received Wegman authentication code. And if you open the cloud server, here we can observe that there is data received from two port numbers, because first we have searched for some other vehicle. So this is the data received, and just now we have searched for the vehicle number 17. So here we can observe that request received from client IP. So this is that, and this is the port number. Let's search for some more vehicles. So click on, select the some other vehicle. So now let's select here, let's specify 29. Click on search encrypted data. So this is the searched vehicle. And here are the top 5 vehicles searched for the encrypted data. And this is Wegman authentication code. And if you open cloud, here we can observe that request received from the client IP. And this is the port number from which the data has been received. So minimize this. Now let's click on time consumption graph. So click on that. So here on x-axis, we have the algorithm name, that is the existing or the proposed, and on y-axis, we have the computation time. Here, blue color line represents existing time and the orange color line represents the proposed MRDADS time, that is the proposed model. So the proposed model has taken less time to send the data, to encrypt the data, and also to search the data. So this is how to execute the project. So this project, multi-receiver data authorization with data search scheme, is a game changer for the Internet of Vehicles. It allows vehicles to communicate securely and efficiently, improving the road safety and reducing traffic congestion. So, this project not only enhances the awareness of the road conditions and potential hazards, but also enables multiple vehicles to access important information if it is further improved in the real time. But fostering collaboration among vehicles contributes to the creation of the smarter transportation systems that can adapt to the needs of users, ultimately leading to the safer and more efficient roadways. So, this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.